what you have been doing so far before I start with chapter 2?
Nope. 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 Go and
So
get.
I want to go over chapter 2 quickly. It might take us maybe about 30 minutes. And I want to encourage you, if you don't get me, if you don't understand anything, just stop me, let me know. You can just speak it out because we are going to record this discussion so that it could be useful to other students as well. I'm going to be doing this as often as possible. For it's not mandatory because it is difficult to have everybody available at the time. So for those who are available, we are going to do uh, we are going to go over either homework or a chapter and record it. Okay. So in chapter 1, we learn about how to collect data, which is the first step of doing statistics. In chapter 2, we are essentially going to learn how to organize data using a frequency distribution table and how to construct some graphs. A frequency distribution table essentially displays the data value with the number of times those values will occur. And we can use a graph to represent those data. So for example, on the screen, can you see the screen? So can you see the screen, Michael?
Yes.
Okay, so on the screen we have a data that are collected, which are the blood type of some 25 individuals. These are 25 Army inductees. And when we have data as they are here, there is no much information we can get about it until we organize it by listing each blood type and the number of time, the number of people having that type of blood type. So one method is to read each blood type and put a tally, as you can see on this table. And then as we read through all the data values, we put the tallies and count the tallies at the end to determine the number of people that have that blood type. So that is what we call a frequency distribution table for qualitative data. We could do the same if it was about these 25 individuals' ages. So for both quantitative and qualitative data, a frequency distribution table consists of determining the number of times each value occur and to present it on a table. So in addition to this, we have the percentage for each of those categories. So when we have single values for numbers, we can do the same work as we did for the blood type. But when we have too many values, we can decide to group them into classes. A class will be like saying 1 to 5, 6 to 10, 11 to 15, in order to group the data and to reduce the number of categories. We will now simplify it by making a group frequency distribution table. Here we have, for example, a class from 1 to 5 means that the lowest possible value of the class is 1 and the highest possible value is 5. So values that are between 1 and 5 are also part of the class. So when we have a class, we can make a class boundaries. That is to determine boundaries within which values of the class should be. To do that, generally, we subtract zero point 0.5 from the lower value and add zero point 0.5 to the upper value. So the class boundary for 1 to 5 is zero point 0.5 to 5.5. Another way to represent a class is to get the midpoint. The midpoint of the class is the average of the upper and lower value. The upper value here is 5 and the lower value is 1. The average of these two numbers is 3. So the midpoint of the class 1 to 5 is 3. So essentially what we are saying is that we can group data into classes. These classes could be represented by the class limit, which is 1 to 5, the lowest and the highest possible values of the class. It could also be represented by their class boundaries by subtracting and adding 0.5 to the values, or it could be represented by the middle of the class, the midpoint of the class. So now when we have large number of data values, to group them is not always an easy thing because we want to group them into classes in such a way that all the classes have kind of the same width, that is the same length, and then all values can found a class where they could go. We do not also want to have overlapping in two classes in which we may not know where to put a value. So in order to obtain classes that will satisfy those conditions, we will follow the 5 steps that I have listed here. The first step will be to compute the range. Actually, it's 4 because I combined the first and the second. The first step would have been to find the highest data value and the lowest data value. Now you look into all the data value, the raw data that you have, you identify the highest value and the lowest value, and you subtract them to get what we will call the range. The class width is the range divided by the number of classes you want. You felt like the data values were too many, maybe 50 of them, maybe 60 or 100, and you may want to reduce them into 5 classes, 7 classes, or 10 classes. Generally, people want at least 5 classes, at most 15. Or let's say maybe some people will go up to 20. Not too many classes anyway, in order to resolve the problem of the fact that there were too many values. So the width is obtained by dividing the range by the number of classes that you want. Now, once you get the width, we are going to do one example that will help us to illustrate this. Once you get the width, you can use it to construct the first class by identifying the lower class limit, which is the lowest data value, and then the upper class limit is obtained by adding the width and subtracting 1 unit. This will help us to get the lower and the upper value of the class limit for the first class. Then once we have the upper and lower value for the first class, we keep adding the width to lower and upper value to have lower and upper value of the next class. Let's look at an example that will help us understand better. Consider these data values. Here we have the following data represent the record high temperature for each of the 50 states. Construct a group frequency distribution for data using 7 classes. Here we have 50 values, and we will identify the highest data value and the lowest data value. If you look through with me, you can see that the highest data value is this one. 134 is the highest temperature for the 50 states. And the lowest data value is 100. These two numbers are going to be useful to compute the range. The range will be 134 minus 100, which is 34. Now, if we want 7 classes, we are going to divide that range by 7 to get the width. Let's move to the next slide to see the computation. So we get the range by subtracting the lowest value from the highest value, and we get 34. And we use that to compute the width. The width will be 34 divided by 7, which is 4.8. And we round it up to 5. We always round up to the next whole number because we are dealing with whole numbers. When we deal with whole numbers, we round up to the next whole numbers. If we deal with decimal numbers, we will round it up to the next decimal number. If it is 1 decimal number, we round it to the next 1 decimal. If it is 2 decimal, we round to the next 2 decimals. This I'm referring to the data values. So we have a width of 5. Now we'll go back to the data value. To construct the first class, we identify the lowest value, and the lowest value is 100. And we add the width to 100 to get 105. And then we subtract 1 to get 104. So the first class will go from 100 to 104. Using this procedure, after getting the first class, the next class will be adding the width to the lower class limit of the first class, which is 100. We add the width, which is 5. So the next class will have lower value 105. So the first class here is 100 to 104. Now, by adding 5 to 100, we get 105. Adding 5 to it, 110, and so on. We keep adding the width to get the lower values of the next class. Same thing for the upper value. Add 5 to 104 to get 109. Add 5 to it to get 114, and so on. Now we will go back. But before we go back, we can compute the class boundaries. Class boundaries here are obtained by subtracting 0.5 to the lower value and add it to the upper value. You can see here we subtracted 0.5 from 100 to get 199.5 and added 0.5 to 104 to get 104.5. So that is how we construct a frequency, the classes. Next, we could compute the class midpoint, which we have not done here. We will now go and look into the data values and use the method of tallies as we did for the first example to determine the number of values that goes into each class. You can use the tally and then get the frequency. So if you read a number, for example, let's go back to the data. 112 is the first number. 112, we go to the class 110 to 114. Then the next number, 100, will go naturally to the first class. 127, we will look at the class that contains 127, is the class 125 to 129. In this way, you will be able to get the frequency for each class using tallies. Now, once you have the frequency, you may have what we call the cumulative frequency. Cumulative frequency is obtained by adding the frequencies that are before the class you have to the frequency of the class where you are. For example, the first class will remain 2 for the cumulative frequency. The second class, we will add 8 to 2 to get 10. Then we will add 18 to 10 to get 28. We will add 13 to 28 to get 41. So this is how we can get the cumulative frequency. So now, if we have our data values, we have class boundaries and class frequencies. We can use it to compute. We can use it to compute the cumulative frequency. We can use it to make a histogram, a frequency polygon, or an ogive. Those are the graphs that we can make. Those are the graphs that we can make. We are going to learn how to use Excel to make each of these graphs. So at this point, I want us to use Excel to learn how to make those graphs. But before that, I want to explain what each of the graphs means. A histogram is a graph that will display data values and their frequencies using bars. That is, we are going to use uh, bars that are proportional to the classes. So 1 minute, I'm going to get Excel. Do you have Excel? So now we are going to use Excel to construct a frequency, a histogram, and all the other graphs anyway. So the first class was 100 to 104. The second class, 105 to 109. Then 110 to 114. Then 115 to 119. Then 120 to 124. 125 to 129. And 130 to 134. So these are our 5 classes. Now we want to look at the data and then associate to this data their frequency. For each of the class, we are going to write the frequency on column B. Column B, we will put the frequency, which is I'm coming back to just show you where I'm getting the information from. These are the classes. You can also see this table in your textbook. And then you can learn how to use Excel. At the end of each section, there is an Excel instruction on how to use Excel to make this table. So the frequency here are 2, 8, 18, 13, 7, 1, 1. I'm going to go back to Excel and write the frequency. The frequency are 2, 8, 18, 13, 7, 1, 1. So here, almost all our graphs are going to follow this method, writing the variable on column A and the frequency we want to use on column B. So I will highlight the 2 columns. I will highlight the 2 columns, and now I will go to Insert. Insert, and I will choose a histogram, which is a bar graph. So this is a bar graph. So this is a bar graph that represents the data that we have. We can decide to reduce the gap between the bars by changing the format here. So the width is here. I can reduce the gap. So this is a histogram. The next type of graph is called the frequency polygon. With the frequency polygon, we use the class midpoint instead of we use the class midpoint rather than the class limit. We could also use the class boundaries to make our histogram. To use the class boundary, we can change each of these numbers into class boundaries and class midpoint. 99.5 to 104.5. So then we have changed it into class midpoint. I'm sorry, class boundaries. So if I was writing class boundaries, that is what we are going to get. Here we will have 104.5 to 109.5. So depending on what we are using, that is what we are going to see on the x-axis. Here we have 109.5 to 114.5. Here we have 104.5 to 109.5. Here we have 119.5 to 124.5. What I'm trying to explain here is that you can use either the class limit or the class boundaries to make your histogram. Essentially, enter the classes on column A and the frequencies on column B. Another type of graph is a frequency polygon. A frequency polygon is like a histogram using the class midpoint, and instead of bars, we use points connected by line segments to represent the frequency. So to compute the class midpoint of these classes, the class midpoint is the average of the two numbers. So I'm going to compute the average of the classes. I can make another, I will make another. I could remove the class boundaries and replace each class boundary by a point. But I want to make another table. Normally, you represent all of this into one table, but because we just want to make a graph, to make a frequency polygon, I will compute the class boundaries for each of the classes. The first class is 99.5 plus 104.5 divided by 2. And that will give me 102. 102. I could also do 100 plus 104 divided by 2. That will also give me 102. Now, and I will add the width, which is 5, to get 107. 5 to 107. I will get 112, then 117, then 122, then 127, then 132. So these are the class midpoints to make a frequency polygon. The frequency are 2, 8, 18, 13, 7, 1. So to make a frequency polygon, I will highlight column B and A and go to Insert. And these are the frequency polygon. So I will choose one that will correspond to what I need. I'm sorry. Before I do that, I will make a fake point to identify 0 so that the polygon should connect to the x-axis. So I will subtract 5 from 102 to get 107 and put 0 for that first class. A virtual class before and a virtual class after. That will help me make a better frequency polygon. Okay, insert, and here. Now I will go to more graphs. Nice. I'm looking for the best graph. Here should be, I'm sorry for this. The 0 here is 97. Subtract, not add. So I will highlight these values and then insert and choose any of these values. This one is a good. So this is a frequency polygon. This is a frequency polygon that represents the data that we have. So you can move it down to see your histogram. So you can also do each of these graphs manually. I just wanted you to see how to do it using Excel. The next graph that we might want to learn about is an ogive, which is a cumulative frequency. A cumulative frequency. So this is an example of OG. The OGIF is a graph, a cumulative graph. So to make a cumulative graph, we are going to use the cumulative frequency. So let's go back to Excel. And we want to use the cumulative frequency. So, and we are going to use the cumulative frequency together with the class boundaries, just the lower class boundaries and the upper class boundaries alone. So I will start here with 99.5, 104.5, 109.5. This is just for those to be displayed on the graph. 114.5, 119.5, 124.5, 129.5, and 134.5. Here we have 2. Here we will have 10, then 28, plus 13, 41, plus 7, 48, plus 1, 49, 50. This is the cumulative percentage. This graph is not what we are interested on. It's because I'm making changes here. So I'm going now to highlight the class boundaries together with the cumulative frequency. Oh, I missed something here. Here is 0. Here is 2. Here is 10, 28, 41, 48, 49, 50. The first one was 0 because there was no value before 99.5. So the first one here is 0. So we will highlight the class boundaries together with the cumulative frequency and choose insert. And then we are, oh no, it's a polygon graph. So we are going to use this one. This is a frequency polygon or OG. Title here. OG. So we can move it elsewhere. So you can copy this and paste on your Word document in case you are doing some work on Word. This is how we make an ogive. It is a cumulative graph. That is, it add up the, you can see that ogive and frequency polygons are essentially the same. It's the same procedure. So you do the same thing. And this is another way to make. I change it to this one by highlighting both. I will have the I will have the midpoint listed below. The first one I had did not have the midpoint. It just show you the graph. Okay. So let's go back to the PowerPoint. So we have learned how to make a histogram, a frequency polygon, and an ogive. Histograms are useful to express the shapes of the graph. Histograms give us an idea of the nature of the distribution we are dealing with. These are classical type of distribution. We have bell shape, uniform, J shape, and reverse J shape. So these are some other type of distributions. So there are other type of graphs that we can do using qualitative data. Qualitative data could be represented using a Pareto chart. Here we have categories like the blood type, which we will use as we did for a histogram, with the difference that we are going to arrange the bars in descending order. This is an example of histogram representing data of, you start from highest bar to lowest. So we can represent for example, the blood type, starting from the highest to the lowest. Let me get back to the first frequency distribution that we had with blood type. Here, the highest is B. The highest is O. So in making a Pareto chart, we will start with group O, then group A, group B, then group A, and group AB. That's just what it means. You can also use Excel to make those graphs, or you can do it by your hand. You can do it manually. We can also make a time series graph. In a time series graph, we represent data that occur over a series of time. It could be like hours. Temperature maybe at noon, at 1, at 2, at 3. And we put a point that are connected by line segments to make a time series graph. You can also do that using Excel, as we did for the frequency polygon. In a pie graph, we have data that we can use a circle to represent each section proportional to its value. So this is an example of pie graph. I can also use Excel to make a pie graph quickly. I will use Excel to make a pie graph for the blood type that we had. Let me go back to Excel. So if we want to make a pie graph, we will represent the data values in column A and the frequency in column B. So the values were A, the frequency for A was 5. Then B, the frequency for B is 7. Then O, the frequency of O was 9. Then AB, the frequency for AB is 4. So we just highlight both the category and the columns. Insert. I click on insert and come and choose a pie graph. For example, this is a pie graph. I can put the percentage for it here by selecting up and get a pie graph. So the last thing we want to learn is how to make a stem and leaf plot. For a stem and leaf plot, we have data that we will divide into two parts. The stem, generally the first digit, and the leaf, the second digit. At an outpatient testing center, the number of cardiograms performed each day for 20 days is shown. Construct a stem and leaf plot. So we are going to make, the stems are represented here from 0 to 5 because the numbers goes from 1 digit to 50 something. So we will go 0, 1, 2, 3, 4, 5 are the stems, and we align the lift behind the stems. When I read 25, for example, I will go behind 2 and write 5. When I read 31, I will go behind 3 and write 1. When I read 20, I will go behind 2 and now put 0. When I read 32, I will go behind 2 and put 2 here. So that is how we write the lifts and arrange it in order. That's a stem and leaf plot. Another type of graph that we can talk about is a scatter plot. In a scatter plot, we have two variables, x and y. X is the independent variable and y is the dependent variable. We plot it on a graph. For example, if we have the number of accidents and the number of fatalities per accident in the 300, in the number of accidents that we have. Here we have a researcher is interested in determining if there is a relationship between the number of wet bike accidents and the number of wet bike fatalities. So the data are for a 10-year period. For this first year, 376 accidents with 5 fatalities, 650 with 20. Is there a relation between the number of accidents and the number of fatalities? So we can make a graph like this. This is what we call a scatter diagram. To make this scatter diagram, we can go back to Excel and plot the values on Excel. You can also do this manually, actually. You can do it manually, just write the values on the x-axis and the x values and the y values. The horizontal line is for the x-axis and the vertical line is for the y-axis. I'm looking for our Excel sheet. Excel is not here. So I'm going to get into another sheet. And here on column A, I will write the X values, 376, 650, 884, 1162, 1513, 1650, 2236, Now is the number of fatalities. So we have the values. We will highlight the values and go to insert. And this is where we find a scatter diagram. Scatter diagram, we will choose this. Now we can include the line, which we will learn later to be the line of best fit when we get to chapter 10. So this is how we make a diagram representing two variables, independent variable X and dependent variable Y. So in analyzing a scatter plot, we might want to determine if the graph that we are having resemble a line or not. When it is a line, we will see most of the point coming along is the same line. It is positive if the line goes from below to above. It is negative if the line comes from above to below. Sometimes there might not be a relationship. So that is the end of chapter 2. I did this essentially for you to see how to use Excel to make your graphs. If you have any question, you can ask me or you can send me an email later. Okay, Michael? Okay, so that's it for today. You can do your homework. And as I said, if you have a question, just let me know.